seen this. So in the last topic that was about generic programming, um, so where you can have one data structure, and that data structure can have these operations, and these operations can act on any data type. Right? So that's the whole point of it. So the advantage is that is now you don't have to repeat the same set of operations. I mean, repeat the code for different data types. So you can simply have these generic data types, say T1, T2. Um, so one of the things that you need to be careful about is when instantiating it, you need to specify the specific data types that should be taken, that should replace T1 and T2, and yeah, create the instance. So we have talked about this type eraser. So at compile time, the type gets erased and it's replaced by the object. But whenever you're accessing these that particular type variable, the typecasting happens automatically. So the compiler takes care of it. So there are a couple of restrictions we have seen just now. So one of them is type parameters cannot be instantiated. So you cannot say new T, right? Again, generic array creation, that's not possible. So on the so you cannot say list object and then create an array of that. And this invariant cannot be broken. So let's say on the right hand side you have the subtype and the left hand side you have the super type. So we had the list example, list of object, and then on the right hand side you have array list of integer. So that is not possible. So those are a few restrictions. Now let's look at these exceptions. Right? So exceptions are runtime errors, and I think so that's why there is this red color. Right? You get this whenever there's this error, even in Java. I mean Eclipse, you get this red colored thing. But anyway, so this is a an example of defensive programming. So defensive programming is important because whenever something goes wrong, right, there has to be a mechanism to come out of that hole in that sense. So for example, there was an error that happened at runtime. So if you don't handle that error, it will result in a crash of the entire application, right, which you don't want. So there has to be a graceful way of handling that error that has happened. And exception handling would help us in handling all these things gracefully, or the runtime errors gracefully. So let us look at how that happens. So yeah, okay, there are a few laws which again talk about things going wrong, right? So there is Murphy's law and Finagle's law, Sort's law. So all these laws, they basically say that something can go wrong at any point of time, and it's especially the case if it may go wrong at the worst possible time, right? Like let's say whenever you're giving a demo, for example, to the TA, something can crash, and that's the worst possible time because you are getting evaluated at that point of time. So yeah, so things can happen, things can go bad, but in this topic we'll see what happens or how to handle that case when things do go bad, right? So the motto by which this defensive programming goes by is you do hope for the best, but you program in a way that you can also handle the worst case. Okay, so let's get started. So all these techniques that we discuss, which is a bunch of keywords, and then how do we use those keywords for the defensive programming. So all these techniques are meant to reduce the sudden crash of the program, right? So which is the risk of failure. So if there's an application and then suddenly something goes bad, so the entire application should not crash, but it should be handled in a graceful way. So that's the that's the whole point of this defensive program. So there are multiple types of programming errors. One is the syntax error, which is the easiest to fix because the compiler already gives you enough hints in most cases to point out the error that was made, and then you can fix that error. And the hardest error would be the logical error. So these errors are very hard to catch because on most inputs it will work well, but there will be some corner cases or some inputs on which it may not work well. And if we do not test those cases, then the code can go into the production, and then let's say after using your code for some amount of time, that error could come out and it can result in a crash, right? Or something bad can go wrong, can happen. So it's harder to fix. Then there is a third class of errors, which is the runtime errors. So again, at compilation time, there are no complaints. It works well. But at runtime, there will be some cases on which it will completely fail and the whole program will crash. Right. So there is a slight difference between these two. So in logical error, you get these incorrect results. Either for all the cases or for some amount of some cases, some corner cases. So in runtime errors, it will result in a crash. So logical error doesn't result in a crash of the application, but this one results in a crash, right? So for handling the runtime errors, you have this exceptional handling mechanism. So there are a bunch of keywords that we'll be using here. So the first one is called the try. So there are 3 keywords basically. So there's a try, catch, and finally. And all these are reserved keywords. They have some meaning associated with them, and they should be used in a particular way, right? So we'll start with the try part. So any code which you think should be monitored or which can potentially result in a runtime error, so that piece of code should go into the try block, right? So this code can potentially throw an error. So all such piece of code should be part of the try block. And catch, as the name says, so if there is an error that happens in the try block, then whatever you do in the catch block would get executed, right? So let's say if there's an error, then you need to handle that in some way, and all that handling mechanism would be part of the catch block. And then there is the third keyword, which is finally, right? Finally is optional. That's the first thing. So every try should definitely have a catch associated with it, and catch should immediately follow the try block. Or try can also be followed by a finally, but right. So you cannot have any. It's not optional to. For example, finally is optional, but catch is not. So you should definitely have a try and catch, but you can optionally have finally. Okay. So the significance of finally is that irrespective of whether an exception is thrown or not, that means whether the catch block gets executed or not, finally always gets executed, right? So let's say there's a try block and there was no exception. Even in that case, finally gets executed. That's the first case. And the second case is that let's say there was an exception. So in the try block, so catch block got executed. But even in that case, finally again it still gets executed. Right? So finally gets executed irrespective of whether there was an exception or not. And generally you use this finally block to relieve any resources, right? So or close any resources. So for example, you opened a file. So irrespective of whether there was an exception or not, you still want to close the file, right? So yeah, so that's when you use this finally.
Sir, but if we do that without finally, then also it will work. So
yeah, it works, right?
So what is the use, like special use for this?
It works in the sense, so you can have so you have your try block and catch block. So let's say there was an exception and catch block got executed. So if you didn't have finally block, you cannot close. I mean, you couldn't have closed your file, right?
The file after this try catch block will be executed whether it is finally or not. So what is the use? Like, the just after line, the line just after the catch block will be executed whether we write finally or not, right?
Oh, after the catch block. Yes, yes.
So then what? Then it's like becomes useless. Like why? Like in sequential flow, it will always do the thing which is written just after the catch block. So why we need an
Hmm.
extra block of finally?
Right, right. So yeah, you are right. So if you don't have so the anything that follows catch would get executed anyway, but typically you tend to end your code block with catch. I mean, so let's say you have a method and you have a try block, and then right after try block you have the catch block. So generally your code ends with a catch block. So let's say you are returning something from the method. If there is no exception, you return, let's say, integer, or maybe that's wrong. So let's say you return an array list, right? But if there is an exception, you return null. So in your catch, you typically say return null, and that would generally be the last part of the code. So you don't, I mean, but if you have some code following the catch, yeah, you can skip finally, and you can put that code inside the, sorry, the code, let's say to close the file after the catch block also. But
Okay,
if
okay.
you are ending your method by the catch, then in your finally you can put in all this piece of code which will close the files and all, and and the method gets done.
So, but in that case, also the finally block will then also follow the catch block only.
No, so that we'll see later. So, for example, there are a couple of cases where okay, there's one more keyword called throws, which we haven't talked about here. But I think your answer would get, sorry, your question would get answered there. So there's
Okay,
something called throws. So you can catch the exception, but you can rethrow it.
okay,
So
sir.
for example, you have there was some exception in the try block. So your catch block would get executed, but within the catch block, you can throw it again to the client, to the caller who called your method. They can, it's up to them to handle it. So you can throw it away. But in that case, your finally would get evaluated first, and then you get come to the catch block. But we will see that case later on. And I think your question would become more clear at that point of time. Okay, so let me. Uh, okay, we'll just take a look at this slide and then we'll be done. So I'll stop. Okay, so we'll just trace through the try and catch program execution. So let's say you have your try block, your catch block, and then the finally block, and then there are a bunch of statements following the finally block. So if there are no exceptions in the try block, then your finally block would get executed right after the try block. So catch block would not get executed because there are no exception. Right after the finally, you have your next statement which gets executed. But suppose there was an exception in statement 2 and it has thrown an exception of type exception 1. So there are different types of exceptions. We will see that in the next couple of slides, in the next class. Right? So let's say it has thrown an exception. Since it has thrown an exception, it will be caught by this catch block. And once it handles this, the finally gets executed. So it always gets executed, like I said earlier. And then you have your next statement, which will get executed after the
So,
finally.
sir, a try block can have multiple catch blocks like for
Right, right.
different exception.
Yes, yes. So it can
Okay.
have multiple catch blocks.
Or
We'll
can
come to that
we
later.
handle many exceptions inside one catch also? Like,
You can do that, but it's not so. You can have a generic exception similar to. Uh, so there's one exception called exception, which is called exception, and it's very similar to your object class. So object class is the parent for all classes, right? So in the same way, there's a class called exception, which is the parent for all exceptions. So you can use that, but it's not considered a good practice. So generally, you keep that exception as the last catch block. but we'll come to that later. Okay, so I'll stop there. Uh, so this is the flow of execution for try, catch, and find loop, right? So with that, I'll stop. So yeah, if you have, and we'll continue from here from the next class. So if you have any questions, do let me know. If not, you can prepare for your quiz